So far in this course, we've talked about various properties of functions, including symmetry, increasing, decreasing, and domain and range. Another property of functions that we'll talk about now is continuity. A function is continuous if it has no gaps or holes and can be drawn without lifting a pencil from the paper. Otherwise, it's a discontinuous function. So here are some examples of continuous functions. So here's an example. So just a generic shape here. So as I draw this from left to right, I'm just marking certain key points here to see the shape. As I draw this, we can see there's no holes or gaps, and if I trace along from left to right, I wouldn't have to lift my pencil from the paper as I sketch it. So that's a continuous function. Discontinuous functions would be something like this. If I took the exact shape I just sketched, so this funky looking shape, but then right here, I punch a hole out of it. So at that point, that function is actually undefined. It doesn't exist at this hole, which we indicate with the open circle. So because of this hole, when we trace, if we were to sketch this or trace it left to right, we would have to lift our pencil here because there's a hole punched out and then just continue on to the right. So that's an example of a discontinuous function. Punch in a hole out of it. Another example would be if there's actually a gap, multiple pieces, and this is leading us up to piecewise defined functions in this section, which we'll talk about shortly. But if we had something like this, so here's a piece of a function, a squiggly piece, but then there's a gap, and it jumps up to here where there's a hole, and then it continues on to the right. So if I trace this from left to right, I would clearly have to lift my pencil here and jump up to this hole and then continue on infinitely to the right. So because of this gap here, this would not be a continuous function. This would be a discontinuous function.